All right, well, welcome to almost the end. We're getting very, very close. We have a couple of things I want to talk about in terms of concepts, and then we'll start in with some programming. So the first piece is I want to talk about this idea of functions, and we introduced them the last couple of weeks, but we want to add a little more to our function knowledge. So if I can get the cursor to go over to the real left side over here. So I want to talk about what a function is, how it works, and a couple of things that we can do. So a function really is just an individual section of code that can stand alone for the most part. It gets input in, and it can return. Now, it can return data, it can return values, it can return nothing. Sometimes that function is truly standalone, and it's what we call a void function. It doesn't return anything back. So we pass in things, and we typically call them arguments. We're passing in values into that function. A function cannot see data that is created as variables in the mainline code of a program. And it can't see variables that are created in another piece of code, so another function. The only way we can do that is if we have something what's called a global variable. And very infrequently do we use those. And part of that makes common sense. If I had a program that at some point used a social security number, I don't want that available everywhere in that program. So functions give us that level of keeping things apart, or another way we think about it is something called abstraction. So by creating functions, it's actually easier to design our program because we can use fairly large things. And our book uses this example of do the laundry. Well, I don't need details about the laundry when I design my program, but I can design that function in there for doing the laundry. So we use this abstraction. Partly it's a great way to remove that so we know that my program has functions and it's going to do various modules. I can also then break up the coding into teams a lot easier because I'll assign a function. So one function may be enroll in school today. That may be a function that we put together. So we break up our programs into these little abstract units in there. So here, for example, we have all this code, but we don't need to see all of it. All we really need to do is we need to remember what summation does. And in this case, we put a lower and an upper value into it, and it spits it out. Repetitious things. So if I'm asking for data, so I'm asking for a user input, and I want to sanitize it, I want to clean it and check it for things, I'll a lot of times put those off into sections all by themselves. So it hides all those things from us. It makes life easier. Once I've designed it, I typically reuse a lot of those functions. So at some point, there's functions for things like adding numbers built in. We don't have to see the details. We just know that we need to call a math.something function, and they're already all built in. So algorithm is another term for how do we solve a problem. So one thing we can do is make our algorithms fairly generic so that our same function can solve a myriad of different problems depending on what input it gets into it. So functions are really something we do. So that division of labor, so in other words, I can assign other programmers, other people on my team to design those, to move those about. So there's a couple of different ways that we can look at an overall problem. And so one of the ways we can design is top down. So in other words, we look at the entire problem. So top down, Peru State College needs a system like MyPSC. That system is designed from the top, says these are my big functions, and then I fill in the details as we start to design it. So that's top down. You can also do top up, where you already have solutions to all the smaller pieces and you put them together. So a lot of times what we want to do is we want to create a program. So in this case, it's sometimes easy to diagram out and see that my functions, how they interact. So here we have our main on the left. On the right, count sentences. So it takes a string in and it returns an integer. Count words takes a string in, returns an integer. Count syllables takes a string in, but count syllables actually has another function called syllables in. So that function passes it to another function, returns back an integer, which returns that back to the mainline code. So as we go down, 3 integers in, and we return a float out. So these kinds of high-level diagrams, so we don't have to have all the details of how we count sentences, count words, any of those yet, because we're designing that mainline programming code here for it. And then one last thing I want to talk about is something called recursive. So recursive means we're breaking something down into smaller pieces, and they will essentially call themselves. And I know that seems a little weird, but rather than have to write out a loop, we can actually call a function repeatedly, so a function will call itself. And so we're going to see that here in a little bit when we start working on some of our problems. But what we'd like to do is, instead of having this while loop, in some cases it makes more sense where we're actually calling. So notice our function, if lower is less than upper. So if that value is true, we print the lower value and we call this function again. But we increment lower by 1, and so we come up again and we run those repeatedly over and over again. So recursive functions just mean they call themselves. That's the only thing that is really odd about those. All right, now that we went through that, I'm going to pull up some of our material for this week. So I'm going to go to week 12 or week 13. Week 13, a few weeks out. All right, so make sure you've done the reading. There is a review. There is a practice. The crossword puzzle seems to actually work in this chapter. There is a visualize, so there's an animation in here. I would encourage you to do that. And then there is a quiz in here. Nothing unusual. And we've only got 3 assignments. So I want to take a look at 6.1 first here. Slowly we can load it. Flashcards are great. All right, as it's slowly loading here. All right. So in this case, we've already got some code. So we're going to look at that. And what we're trying to do is approximate square roots. So Sir Isaac Newton actually came up with this methodology. And it's iterative in that we take essentially a guess, and then we say, oh, nope, that guess isn't quite right. Let's improve that guess, and let's see if we can continue to function a little better. So let's take a look at what we have here. So we're trying to get 2 different values out. So value 1 is the estimate from our programmatic code. Version 2 is using the math function that's built into Python. So let's take a look at what the code they provide already. So a couple of things we need to think about. So here we're getting a number, so they've already provided that, and we converted it to a float. We normally think, well, let's just make it an integer, but in this case we want the decimal points. So we're going to convert that to a float. And we have an initial estimate. That initial estimate we just set to 1. We have a loop here. So this loop will run as long as some condition is true. So this is going to run until it breaks out, because we don't have anything to ever change that to a false. So this loop will essentially run forever until we get difference is less than tolerance. All right, well, what do we mean by difference? So our estimate, so we started out with our estimate as 1. So our estimate is equal to estimate plus x, so the value that we received in, divided by estimate, and then the whole thing divided by 2. So we've just gotten this formula. So we could see what it would look like if we put it into Excel, but essentially what we're trying to do is get as close to an estimate value as we possibly can. And then the difference then is the absolute value, and that's a function we haven't seen yet, absolute value of x minus the estimate, but that estimate is raised to the second power. So it's squared. So x minus estimate squared. So what we're trying to do is get this difference less than what our tolerance value is up here. In other words, we're wanting to get out to 6 decimal places out here. So as long as that difference is greater than our tolerance, then we're going to continue to loop. So one of the things I like to do is actually to see what's happening in here. So I'm going to put in a print statement, and I'm going to print estimate, and I'm going to print the difference so we can see it as it runs through here. So enter a positive number. Let's see if I can move this over a little bit to make it easier to see. So enter a positive number. I'm going to put in 10. So initially, the first time through there, our estimate was 5.5. Well, obviously, that led a pretty good difference when we looked at the difference of those. So we said, all right, well, nope. Let's try again. So we ended up with a 3.659. Our tolerance is still too high, so it did it again. Now we come down, and as we get closer and closer and closer, our estimate gets smaller. So this is actually scientific notation, so it's 3.1, and then there's an additional 8 zeros, negative 8 zeros packed in there. So we're below our estimate at this point, and so our estimate for this program then is 3.162277665117, blah, blah, blah. And notice it's very similar to 162277766, and then they diverge at this point. So they're just a little bit different. Well, we could try, and we could say, well, maybe we need a bigger tolerance. See if we can make this very similar. We're going to put in 10 again. And so here it did one more iteration. So 7979. You see we're off, but at this point by just a little bit. So it's a method that we can use to find this square root. Even if you had to do this by hand, you could do an operation like this by hand. So in this case, it looped 3, 4, 5 times. So it's a pretty quick way to get down to that square root, or a really close impersonation of it. For most of us, we're not going to know the difference between something 12 digits out And in fact, we're getting really close to the limits of what Python can report and accurately handle in terms of digits past the um, decimal point. So, what is it we need to do here? So what we're going to try to do is to change this a little bit. And we're going to change this so we put it into a function so that we have a main and we have a function called Newton. All right, so we know this works. How do I change this a little bit so that we can make it a function? So I'm going to do this because I think it's a little easier to see it in something like this. So I now have a blank slate and I have my pieces up here. All right, so I'm going to grab all of it except for the quotation parts. And so I can put it in here. Chunk. All right, so same program. It's just a little easier to work with because I don't have the weird screens on either side. And you'll see that this would actually work. So if I run this, I have to save it somewhere, so I'm going to call it Newton. Let's call it. Already had a name of that. All right, so if I run this, it says, all right, here's my positive number. And because I have those print statements in there, it still works. Great. But now we need to think about how do we define and change this into a function. So this piece is what we're probably going to, this is the part that actually does something. So we're going to actually make that a function. So our tolerance up here, that we can leave where it's at. And so now, instead, I'm going to say, I'm going to define function called Newton. All right. So Newton needs a couple of things. So to define a function, I use DEF, define, and I'm going to call it Newton. And in this parenthesis, I need to say what is coming into the function. Well, I'm going to take a single value in, and I'm going to call it x. Now, here's where it's tricky. I used x here, and I used x here. They don't necessarily have to be the same name. I'm just using it as a kind of a temporary cast-off variable. So, define Newton. So, I can do the same thing with, I can do like comment codes in here and say, this function returns a square root of value x. All right. So obviously I got to do a little change here with my indentation because right now the only thing that's in this function is this, because it all has to be that block level indent. Well, luckily, one of the things that we have going for us in a tool like this is if I go up to the format, notice I can indent the entire region, and I can actually make this part of that block directly that way. So it indents that entire region. So I highlighted it and I moved it. All right. I need one other thing in this. So right now, I do have a print statement in there, but temporarily, I'm going to make it go away. So I'm going to get a value back out of this function. And I need that value to come back to me. So I calculated something called an estimate, and we know that estimate then is what we want to return. So I'm going to return estimate. So if I call this function and I send it in X, it's going to return my estimate. So I'm going to go down a little bit. All right. So couple of pieces in here. I'm going to also create a second function. All right. So I'm going to define one called main. And main is going to be a void function. Nothing gets returned out of main, or nothing goes in directly into main that way. But in my main, I want to take a number and get a number. So I'm going to actually move this piece here. I'm going to cut it. So Control X will make it go away. V makes it magically appear. So I'm going to say, here's my value. I'm going to get a value. I need to actually check and see if this value is what we want it to be. So one of the things a lot of times we'll do is we actually make this a loop. So I can simply do while true. So, and we don't have anything to change yet. So I've now made everything that comes down here actually in a loop. So one way I can get out of that loop is I could actually use an if statement. So if x equals, and if you just hit the enter key so it's blank, I'm just going to use the break. Not my favorite way to get out of there, but it's an easy way to make a loop. So that break will then run the rest of that code out. So otherwise, I need to convert that to a float. Well, I can do it here, I can do it here. The problem is if I did it up here, I wouldn't be able to compare it to a string, so we'd end up with a problem. So this time it makes some sense to say x equals float of x. So now I'm converting it to a float down here, because remember, everything we input is a string. And then we're going to move these up. So I'm going to go like this, highlight those, and I'm going to go to the indent. So I'm going to indent, and I'm going to indent twice to get to the proper location. So even though there's some blank lines in here, which we can delete, these are all part of the main function here now. So it's going to print the estimate. It's going to print that. Or is it? So I need to do a couple of other things. I can't see estimate, even though it's up here. I returned it, but I don't know how I got it yet. So I can't see it directly, so I'm going to have to actually call that function. So my print statement, and I can do it right in my print statement, so I can just say Newton. So we're calling that function Newton, and we're putting in x. So we're sending the value of x into it. And then this won't change, so we're still doing the math.square root to find out what's going on there. The only thing left is we actually have to call the main function. We're actually going to do something, and it's called using a constructor. So what it really does is check to see if there is a function named main. If there is, it calls that function. Underline, chunk. All right, so if name essentially is equal to main, then we run main. And notice we don't pass any values into this. We don't do anything else. So we've created two functions in here. One is the main. So the only code that really is on our mainline code is this. And my tolerance is up here. So I still need that import math, and I tend to put it up in the header area. And here, I've got my tolerance and my estimate. But it might even make sense to move that estimate down here so that it's available, because otherwise I'm going to have to pass in that value. Does that make sense? Because otherwise it's going to start with a blank value. So I'm going to cut this out, X, and I'm going to actually pop it right in after my code. So the reason is I wouldn't be able to see that. I have two variables I'm using, and we only passed in one. Now, the other way to do it, I could leave it up here, and then I could actually use two variables, y, and I could have y equal to, but for now, we know that that is kind of like a number that's not going to change a whole lot, like one of our assigned values. We're not going to change a lot, so it's probably easier to put it up here. So all right, so we know we have to have that import math function. It doesn't hurt this function or this until we get to that math.square root, and if we didn't have it, it's going to yell and say, I don't have a function for that. All right, so let's see if this actually runs and how badly I have screwed up my code here. Right next to which one? Oh, I did, didn't I? Yep, that would still. All right. Run. Return estimate. So somewhere I've missed something above that. There's a colon, estimate while true. Estimate equals estimate plus x divided by estimate divided by 2. Nope, that's fine. If difference, less than or tolerance, break. Return estimate. Why does it not like that? Have I got these too far indented? Let me. All right, run. Invalid syntax. So I've got something in my constructor. Weird. What have I done? Let's do it this way. Usually I just have this in my template. All right. So we're going to enter a positive number. And so in this case, it says the program's estimate is 3.11, blah, 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 blah. Python's estimate is, so what might make it easier here, let's do this. So 10. So this shows that that difference there is that last digit. So now we've got a module, and we can use this function then anytime. We can just pass a single value into it. So even if in that main we wanted to do, we could call it at any time, print. And you don't have to do it in a print statement. That just kind of is handy. And then we could actually just pass that in. Newton 15. And that would actually then also enter a positive number, 10. Down at the bottom there. And drag this up a little bit. So it's also going to then show you the value of 15 because we throw that function in. So we don't have to rewrite that code over and over again. We just have to use this function. So now we've got another function we've defined. So, and then notice it says, oh, enter another positive number. So I could actually enter 4. Now, interestingly, we know that 2 the square root is really 2 for 4. But notice it scrolls all the way to the right, and we're still estimating, and it's going to have an issue there. So there's some other things we can do to correct this and make it a little better. But for now, this is kind of a good first start on how do we run a function and how do we do something like this. So I'm going to delete that out. So what I tend to do is I tend to create, and I know it's a little harder since we're using Cengage in some cases, but you can still do the same thing, is I will create some templates of basic pieces I want. So I know that I want the constructor at the bottom. I know that I will typically want, my name and some of these other functions. So I will tell you the two that I use the most are the math and the random functions. So I do the random a lot for whatever reason, and then the math function gives me all those math functions. What I don't want to do is create a template where I'm importing 30 different libraries and never using them. If I import math and random and I'm not using them extensively, that's not a big deal. But I can create this template, and I could have assignment number or other details on here. So now I can save this and reuse everything except this then the next time, or even delete that out and create a template of it. But I've got a function called Newton. That might be handy. I may need to utilize something very similar to that. So now that I've created that, where'd I go? Now I can take this and I can say, all right, well, let me try this. I'm going to copy it. Come back to Cengage. All right, so now I need to delete all this. And I put that into Cengage, and then I can actually try to see if it'll run. Chunk. One of two checks pass. So something it does not like. And I'm going to guess I know the reason why here. Import Newton. So I got values, but remember up here I had changed that tolerance level? So I'll have to reset that tolerance to, I think I added 2 zeros. So now, there we go. So anything I change in there, it changes the output. So it actually tried to find that function. So if I had changed this name to something different, it's going to fail. I will say that this is not always the greatest system for parsing through code. So if you're getting the same number over here, and everything should work or you think it does, send me an email. You cannot send directly a Python file, as we've discovered. But what you can certainly do is copy and paste this in as a text file, which it really is all it is, and we can take a look at it and see if it should run. So the biggest issue I've seen is coming from something like an editor like this, is those indents. You have to make sure that those indents are done correctly. So if I screw up my indents, the program isn't going to run correctly. So if I had those back here, now my program looks similar, but when I actually go to run it, watch what happens. It's going to give me an error of some sort, and it's all due to the fact that we didn't have those moved out. So the indenting is probably one of the hardest things. All right. Well, now that you guys have all seen this as an editing tool, I'd like to look at one more that's a really handy thing to do. So at all of our computers here in the lab, we actually have an app that we use that's free called Notepad++. So some of you may have used that in other courses, but Notepad++, let me delete all this goodies that are in there. So we don't need an index file. Well, let's just do a file new. So I can have a blank environment here, but notice if I come over here to language, I go to, in this case, P. Oh, look at all the languages that something like this tool can understand. I now put my function in there. And this can be a really great editing tool because notice it gives me a lot more control and I have a lot more abilities to do things than I do necessarily just in that very simple editor. So the color coding's a little better, but notice here where it actually shows you this function so we can keep track of it. So if I did something dumb, it shows me those different levels of indent. And there, when I move this out, it shows, oh, my function ends down here. So this is a really great tool. I didn't introduce it on. I didn't want to throw another wrench in there. But if you've used this before, you can actually use Notepad++ for not only, like I said, Python and for HTML, but you can use it for a lot of different things. So if I look at language, and I looked at V, for example, we have all different kinds. Text, you have shell. It actually has, for any of your mathematicians in there, it's got R or an editor for R on here, which again is really just a text file, but some of these editing tools come in really, really handy. The biggest thing that I like about this, and I know this is weird, is when you get an error, and your code is usually longer than a single page, on this, I'll get an error and it'll say on line 37. Well, it's kind of hard for me to find line 37. It's down at the bottom and it's not very, very user-friendly. On this program, or a lot of other editors, the line numbers are right out here on the left, and I can go, oh, line 30, whatever, 27 maybe. And I can find that right away. These also will help you do things. So if I start a print statement, for example, so it'll tell me if I don't have an ending parenthesis. It'll yell at me, and I can see it pretty quickly what I have in there. So I like this one. There's some even better ones that are more tuned to Python, but this one's kind of handy because it will literally go into about any different language you'd like to use. So Python, there are, if you really like Ada, it's actually in there, or COBOL should be in there. So it doesn't have everything for every language, but it's kind of handy to have all of those available really, really quickly. And it's also got some other tools, and you can do all kinds of things with it. You can run macros and do a lot of different pieces with this. Again, this is free. The only downside to Notepad++ is in the past, and I won't guarantee that it's not the same now, you have to be a little careful when you download it because it will try to download some items that you don't necessarily want. So it will try to say, hey, how about you add File Manager 37 or something. So just watch it if you use it to download it. All right. So Notepad++, another great tool, and it happens to be free, which is kind of my theme. I'm pretty cheap. All right, so we've done this one. We could submit it, and now we have assignment 1 in our book done. So let's take a quick peek at 2. We probably won't finish it. We'll finish that up probably on Thursday, but let's take a look at it. Start assignment. All right. So now we're gonna take this function that we already had, And now we're going to turn it into a recursive function. So in other words, we're going to take what we had here, or something very similar, and we're now going to make that a recursive function. So instead of doing a while loop, we're going to pass this back to the function itself. So very similar to what we just did. Let's see which tools I have available here. So if I remember from my slideshow, so here's a function that calls itself. So we have an if statement, we have our thing, and then, instead of having a loop here, it says display range lower, +1, and upper. And it passes both pieces in there. All right. So give us a hint on what we're going to do here. So our main probably doesn't need to change. So we're really working with just this function in this particular program. And we can check, make sure, does it really work? Yep, it does. And notice we can tell it's not ours because we took out the extraneous pieces here. So we're not printing every time, which is kind of a handy thing to do. All right. So let's take a look and let's think about what we can possibly change here. So the estimate, well, we know that estimate is going to change a little bit. So our estimate line, so while true, well, we know we're going to get rid of that. So let's just delete that right off the bat. Chunk. So the next piece then we need to do, we need to unindent these. So not as handy tool in Cengage as there is in most editing tools, but we'll back these up. So we've gotten rid of the loop. The next piece we need to think about is, how do I figure out what pieces to move in and out of this loop itself? Because we only take in one value. But I think we need to also take in a second one. So the first thing I'm going to do is add another number in here. And I'm going to call it estimate. So we're going to pass in x and estimate. So we need to change this down here just slightly. So we also need to pass in x and estimate. So we need to figure out where we get this estimate, and it needs to probably come out of there. So Control X makes it go away. And we can put it down here in the main, actually, anywhere we wanted to. So I don't want it on that line. Let's go back up one. So we need the estimate down here in, it's wrong. There we go. So estimate's down here. So now when we call this function, we pass in both the x value, so in other words, what we start with, that 10 in this case, and we also have this estimate. We're going to pass both of them in. So now we have a program that takes in two values. So x and estimate. All right. So we need to do a little different here. So if difference is less than or equal to tolerance, instead of a break, we're going to do a return. And what we're going to return is estimate. Okay. So our else statement then, else, so if we haven't found a solution yet, we need to find out a way to put data back in there. And so this is our recursive piece. Because what we want to call then is we want to call this function itself. So what we're going to return is not the estimate, but what we're going to return is we're going to call the function itself. So we're going to call Newton. Now, what we're going to return into Newton, we need to pass in two values. So we need to pass in x. And weirdly, because we've already went through there, I'm going to take this piece and actually move it in here. So what I'm going to return is x and the estimate of x, but I don't need this equals piece in there because I'm going to delete that. So this time I'm going to pass in a value, but I'm going to move this piece out of here. So now I just have this difference, and I'm going to put the math in here, which, do I have enough? 1, 2, 3, 4. Okay. So my x isn't going to change necessarily. So that's the value that we get in from the user. This, though, my difference isn't going to change because we'll calculate that on the fly. However, we need to change this every time we run through that loop. So let's see what happens if this runs. Let's try it. So run. All right, so we got some kind of an indentation block error. Hang on. Probably because I have all the blank lines. Oh, hang on. That one's off one. There we go. All right, again, Python is really picky about, where's my next one that it doesn't like? Somewhere in here I made it mad. Indented block, wrong. If difference equals, that should be right, that should be right. Oh, hang on. That one's got to go in 1. All right. So we're going to put in a number. So I'm going to put in my 10. And, oh, I get kind of that same number. And instead of having to run that while loop, now we have a little easier way to do it, I think. So we're passing those values back. So we could check this. So we could say, all right, I want to print at every time. So I want to print, and I want to print x, and I want to print the difference maybe. So I could put those in there, and I could run it the same way. And we could see that it starts with, so there's my x, first time through, second time, third. So as we get closer and closer, you can see how our tolerance then is going down. So we can take that out. So all we're really doing is we're taking that, instead of having just a while loop, we now have what's called a recursive function. We call the function itself from within itself. So from this function, I call myself over and over again. Now, if I had not put in here where we change that estimate piece every time, you can get into a loop where you never get out of. So it's just like a while loop that's stuck, or any other kind of loop. So that's all we're doing, is we're making this recursive. In other words, it returns itself. So not the only way to do it. There are hundreds and hundreds of different ways to do this, but that might be one take on this particular assignment. All right, so if you look at the book, That leaves us with only one assignment left this week, so we will talk about that on Thursday. And there is a discussion board. So before you even post, I'm going to give you some of my thoughts. So a couple of things. Cengage I thought was going to be a little more hands-on, instead of giving you information. The samples they showed me, they looked at it, and a lot more than obviously what this is. So I think in future iterations, I'm going to do a couple of things. One, I'm probably going to go to a much cheaper book. So if this is your only class using Cengage, it'll be cheaper. So that part's good. Now if you're using Cengage Unlimited, and multiple classes, then it's probably a pain for you because you'll spend another $10 or $15 or $20. And I'm going to go back to where we only use the idle programming environment for the semester. So I'm not sure the Cengage piece has actually added a lot of value in my opinion. So, but I welcome yours. What other things can we do? What would be helpful? I know one thing that will probably get thrown out is a simultaneously Zoom link instead. The problems we've ran in historically, but I'm certainly willing to try it, is finding a time when all of us can meet at the same time, or 90% or whatever it is we do. So I welcome your input, and I will see you guys on Thursday.